Hello viewers, in today's class we are going to discuss one important indefinite integral in which we have to make use of the method of partial fractions, right? So here we have the integral I is equal to x plus 1 over x square plus 1 x, right? And we have to evaluate this integral, right? So here what we will do, will adopt the method of partial fractions, right? So let us first observe this integrand which is a rational function, right? And here this rational function has the numerator and the denominator, which are both polynomials, right? And here x plus 1 is a linear polynomial, and here in the denominator we have two factors. One is x square plus 1 and other is x. Now x square plus 1 is a quadratic polynomial, and this is a linear polynomial, right? So here we see that the denominator it consists of a quadratic polynomial and linear polynomial. So whenever we have a quadratic polynomial in the denominator, then we assume a partial fraction of the type ax plus b over x square plus 1, right? And for the linear factor we have the partial fraction of the form c over x, right? So now we can add both these partial fractions, and we have x plus 1 over x square plus 1 x is equal to ax plus b over x square plus 1 plus c over x, right? So what we have done here, we have written this rational function as a sum of these two partial fraction, and this partial fraction corresponds to this factor, and this partial fraction corresponds to this factor, right? Since this is a quadratic polynomial, so we assume ax plus b form in the numerator, and this is a linear factor, so we assume a constant, simply a constant c in the numerator, right? And now our aim is to find out the constants a, b and c, right? Now for this, what we will do, we'll take the LCM, and we have x square plus 1 x, and here we have ax plus b, x plus c times x square plus 1, right? And now we see that this is x plus 1 over x square plus 1 x, and here also we have x square plus 1 x, so we can compare the numerators, right? So comparing the numerators, we get x plus 1 is equal to ax plus b, x plus c, x square plus 1, and now we can rewrite this expression as ax square plus bx plus cx square plus c. And now we can rearrange these terms, so we can write a plus c, x square plus bx plus c, right? So now we can compare both sides, right? So we see that this is the left hand side, this is the right hand side, and in the right hand side we have a quadratic polynomial, and in the left hand side we have a linear polynomial, right? So if we compare the coefficients of x square, x, and the constant term, then we have a plus c is equal to 0, because here we do not have any term containing x square. So we can also write it like this: 0x square plus x plus 1, right? So a plus c is equal to 0, and here we have bx the coefficient of x is b, and here the coefficient of x is 1. So we have b is equal to 1, and here we have c, so the constant is equal to 1, right? So b is 1, c is 1, and from this equation we can find out the value of a. So substituting c is equal to 1 here, we have a plus 1 is equal to 0, so a is equal to minus 1, right? Okay, so viewers, now we have obtained the values of a, b and c. Now this integral I, it can be written as c, x plus 1 over x square plus 1x is this expression. So we have ax plus b over x square plus 1 plus c over x, and here we have dx, right? Now taking these values of a, b and c over here, so we have minus x plus 1, and we have x square plus 1, and here we have 1 over x, right? Okay, now here separating this expression into two terms, from here we have minus x over x square plus 1, and here we have 1 over x square plus 1, right? And then we have 1 over x, right? Okay, now here see, we have x, and here we have x square plus 1. So the derivative of x square plus 1 is 2x. So what we will do, we'll take half, and then here we can take minus half, and then we'll multiply this x with 2, and we have x square plus 1, right? Okay, and here we have integral of 1 over x square plus 1, and here we have integral of 1 over x, right? Okay, so now see, here we have minus half, and the integral of 2x over x square plus 1 is log of x square plus 1, because the derivative of x square plus 1 is 2x, and we know that if we have a function f of x and its derivative exists in the numerator, then the integral of this function, this whole function, is log of f of x, right? Okay, so here we have f of x is equal to x square plus 1, right? And here the integral of 1 over x square plus 1 is tan inverse x, and here the integral of 1 over x is log of x, and c is the constant of integration, right? So this is the value of this integral. Now we can also write this expression by simplifying it, and we can write it as log, here we have x square plus 1, and taking this minus half to the power of x square plus 1, then we can take log x over here, and tan inverse x plus c, right? Now combining these two terms, we have log of x over x square plus 1 raised to half, and plus tan inverse x plus c, right? So viewers, this is how we solve this problem.